So we have our simple particle system with a couple of states here driving it, and what I want to talk about next is some debugging. So right now we can see what's happening fairly well visually. We actually have the set particle color to state color here. There's also a visual debugging tool, but it's also nice to see what's happening numerically. So right now we can actually go here, right mouse button, where it says test inside null on the line, and show values. And what we can do is look at the properties here, and we'll see it's right now set to numeric, and it's a Boolean number type. We can change its color, its position, where the label is, whether it's just working on selected points or all points. And if I hit play now, we're going to see a whole bunch of numbers, zeros and ones. The ones are wherever this has been set, or wherever it's inside the particles that are red, and zeros are all the blue particles that are outside the null and haven't been set to the one that test inside the null does. So that's fairly simple. You can see what's going on there, and it's a great way of seeing what's happening. But not every node can have an output value. Here, the age limit, I want to know how old the particles are. Right mouse button, show values is grayed out. I can't display it. If I want to see that, I actually need to go in and get the age. So I'm just typing get particle age. I need to set it to something. So I'm just going to do a set data. And I'm going to link the set data into my ice tree. I've got an empty node right there in port 2. I'll bring this here in to value, and I'll just give this a name. I'm going to use a self dot, and it's just a simple test I want to see. So I'm just going age. I'll just do age vn. Now I haven't got an age value in here. If I explore, let me just quickly delete that for a second. Explore, and look on the point cloud, there's age limit, there's age, there's an AO I did before, but there's no age num. But if I type here age num and hit enter, that will add a new property to my object called age num. Now I can preview this here, just right mouse button, show values. I got different options here, numeric. It's a scalar value type. Again, we can give it a different color if we want. The color is fine. Hit play, and we actually see now the age increasing over time until it gets to just below 3. And of course, when it gets below 3, if you look at these ones at the top, you'll see when they hit 3, or they will delete, so they only get, say, 2.98 or 2.96. So they won't go above 3. And that's a quick way of visualizing numbers. Now if you want to visualize something else, let me get, instead of particle age, we can go explore, and we can see something else. We can see particle position, orientation. Let's just go on the point velocity. Okay. Point velocity, right now if I hit play, it's still going to display these in this time as 3 numbers, and you can see this is a vector. But because it's a vector, we can actually go and change it under the value properties, and we can look at it as numeric, as nulls, as vector trails. Let's try vector trails. And now we can see a series of lines that show you the vector of the particle, and you can see as they move out. It's a nice, clear, easy way. Seeing vector numbers is hard to read. Go again, show values again, and we can look at some of the other properties we have here. If you just go vectors, it's just going to be the lines. Trails, of course, give it a little bit and we can look at a few others. Show value properties, point trails. It's just points coming off and here we can see it goes from the center to the point. So it's just another way of looking at how things are moving. So really go in and use these visualization tools to see exactly how things are. Remember, if you can't get the data out directly from existing nodes, it's okay to add a get and a set node. Often I just set it to some new value, so it's not going to affect the ice tree. If I delete this node here and this node here, that's fine. Now I'm back to normal and nothing's really changed. You can also set your own custom values as a way to create different effects and share values between ice trees as well. Another great tool is looking at performance. You'll notice some things go fast, some things go slow. If you actually go to the View, General, Ice Runtime Message Viewer, you'll see this viewer here that shows you all your different ice nodes. If I hit play for a few seconds and then stop, it will give me information on my ice tree and what's happening. As we see at the top, it starts with the emit from surface, generate points. You can see what percentage it's using. 30% is emit from surface, and from that 10% is generate. Initializing the particles is 9%. You can close these down as well and just look at different ones. The stage is using 21%, state 1 is using 16%, the test and solid null is another 15%. And often you'll see like glaring values in here. If you use, for instance, a closest point or get neighbors, I'll just show you that I'm going to add in a neighborhood force, but it's a very processor intensive one. So this neighboring particle force is very processor intensive. I add this one in to my forces as a new force. Hit play. Let's go to our viewer again. Ice Runtime Message Viewer. Just hit play for a second so it refreshes. You're going to see high up on the graph, if I just close some of these down, this get neighboring particle force is pretty processor intensive. It's using a lot of values. If I start changing values around, for instance, increase the cutoff distance, so it has a much larger cutoff distance, it's going to go even slower. And now you can see the get neighborhood particle force is now the most processor intensive node in my entire graph. Just because I increased the cutoff distance to a much higher distance, therefore it has to analyze more particles. So you can really see adjusting values, adding and removing nodes, where it's using what, and really what's going on within your ice tree. So it's a great way of optimizing performance. And sometimes you will end up rebuilding a node because you say, hey, this node is way too processor intensive. I could probably find a better, more efficient way of doing this.